Welcome to the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. We appreciate them as a sponsor. And today, I have the distinct pleasure of having with me Patrick Rainsberry, who works for Autodesk. Patrick, welcome and thank you for being here today.
Hey, thanks for having me. I really appreciate it.
Thank you. Would you mind kind of telling us a little bit about yourself and your role at Autodesk?
Yeah, absolutely. So originally my background is in mechanical engineering, and through the course of studying mechanical engineering, I kind of discovered CAD software and 3D design and just really fell in love with it. And I've been kind of working in the 3D design CAD software industry for most of my career now. And right now at Autodesk, my responsibilities are around mostly Fusion 360 and Eagle, which are some of our newer design software, manufacturing software. And I look after primarily go-to-market strategy, which is basically working with our product teams to ensure that a lot of the things that we're working on today are really in line with the needs of industry and the needs of our customers, and looking at places where we can kind of expand our footprint and what general trends to go after and what people need to see from us.
Great. Do you find that customers are open to and forthright with the information to try and help you to improve your products to serve them better?
Oh, absolutely. I think that's one of the things that usually there's no lack of feedback from customers telling you the things that they'd like you to do differently, right? And, one of the things that we've really been trying to do recently is we've been very open with our community of users. It's one of the things that really attracted me to what we're doing here today is this idea of really engaging our customers in our development process. As we look at the next iterations of our software, we've moved to a model where we are moving very quickly and responding to customer needs in a much more rapid way. And what that means is really engaging our customers through our forums and our community, our blogs and communities, and being very open and transparent with things like our technical roadmap, not keeping things big secrets. We engage people very early on with what our plans are. Then we engage them in early proof of concepts, and we're just trying to be much more transparent about what our plans are so that we can continue to get that feedback of what they actually need. And it's created a much better relationship, I think, just in terms of being able to respond to those needs much faster.
I think customers appreciate that, and they enjoy that. A company, it's refreshing to see somebody take an interest in them and ask them what they like and don't like, and are willing to customize and shift their products to meet their needs. It's always been a fear of mine that companies think you're just supplying a product. And when you do that, the customers feel like it's just that. It's just a product, and I'm just a customer. But when you take an interest in them and into their needs, I think that really builds a partnership, and it's a direction I personally think is very important moving forward in our as manufacturing continues to grow. We have to be responsive to the needs of manufacturers. What do you think about that?
Oh yeah, absolutely. If you look at our roadmap and you look at what we deliver, a significant portion of the things that we actually put into our products are driven directly from our customers. We have a whole infrastructure within our forums, for example, we call the Idea Station, and people are constantly posting these ideas in there, and then other customers are voting on them and upvoting it. And our product team meets, I think it's once a week, and they basically review all of the latest Idea Station posts. They take it into account, and again, like I said, we operate on we set very short sprint development timelines that allow us to just pivot and make changes to the plan and incorporate things at a pace that I don't think that most of our customers actually, frankly, have ever seen anything like that before. And so when we can go from someone posting an idea in the forum to delivering a feature in the software that's going to help somebody to get their job done faster, and we can do that in a relatively short period of time, I think it really captures people's interests.
Yeah, I think it's refreshing to work with a company like yours that has that kind of responsiveness to their needs and as rapidly as you do it. I think that's something that really sets you apart when you're working like that. Tell me a little bit about your 5-year execution phase of your plan for Autodesk. How is Autodesk responding and looking forward to their 5-year plan and planning to execute that phase?
Yeah, absolutely. I mean, when we think about technology, 5 years is a lifetime, right? And so, when we look at these trends, if you can go back and you can listen to some of the things Diego talked about these kind of macro trends that we see in the industry. And I think that's really what we're focused on. If you look at some of the things that we've been delivering recently and some of the things that we'll be working toward, a lot of this really is about this shift of data from kind of these individual silos with individual users with very specific tasks to a much more collaborative, common environment where you see the things like data moving to the cloud and these barriers between different disciplines really breaking down. And so I think our responsibility is to just keep making it easier for people to come together, to not just take advantage of kind of like the existing methods of design and manufacturing and preparing designs for manufacturing, but also looking at a lot of these trends that are coming into manufacturing in terms of automation, additive design, generative design, things like that, and saying, okay, how can we keep moving people towards software that will enable them to take advantage of those trends and capabilities, but at the same time ensure that we're not just creating a bunch of silos of super specific domain expertise where everybody's able to still come together and work off of kind of a common platform. That's really where I think our responsibility is, to make sure that what we deliver over the next 5 years is something that can just continue to be extended, right? So that as we add more and more things and more new capabilities, we're able to just keep bringing it all into like a single innovation platform.
Great. What are some of the changes that you foresee coming down the road in technology that are areas that Autodesk needs to respond to in the future, whether it be hardware or integrating with other software platforms?
Yeah, absolutely. I think that the biggest thing that you see, this sort of industry 4.0 that people talk about, and this massive shift that's happening in manufacturing, you can really boil it all down to this single topic, which is data, right? And it plays out in a lot of fronts. So you have machines that become connected to the internet. And that's not just about being able to, turn your CNC machine on from your cell phone, right? The thing that we got to think about is that as the machines all become connected, your ability to capture information from those machines, to be able to understand, success and failure better. There's the low-hanging fruit, as Diego had mentioned in your previous podcast, of just predictability and predictable maintenance. But it goes further than that, I think, as we start to get more and more data in manufacturing. We have to figure out how we can kind of bring all that together in a way that can feed not just the customer of the machine, but also the manufacturer of that machine, right? So we can create this feedback loop where we can understand how our products are performing in the field, which can drive a better process in our next iteration of that product. I think that this like proliferation of data from the design of the product all the way down through the manufacturing of that product and then ultimately to its performance in the field, tying all that together is a trend that is going to become very much more important in the way things work going forward. These are the things that we start talking about artificial intelligence and machine learning. It's having these massive data sets is what really is going to power the intelligence that I think will become somewhat apparent in manufacturing going forward.
Right. One of the areas I've always noticed is that people find that they try to gather this data and then they want to respond to it. For instance, let's say that you've got a piece of equipment and you're gathering the data off of it, of its performance and everything, and you know that you're running out of material as it's integrating with your stockroom. You know you're running out of material. The next level of things is closing that loop so that rather than my need to, yes, you let me know that I'm running out of material, but take it to the next level and just go ahead and order it, and close that loop. Or if you know that maintenance is needed on these products, go ahead and write a work order for it. Do you see more responsiveness and predictive information coming out of this?
I do, absolutely. Again, that's one of those things where, as we move all of this intelligence of the design process and the manufacturing process into kind of this centralized repository of information, right? You create the ability to start to connect these different systems, right? I think that that's a trend that you see really playing out in a lot of other areas in the software industry, and it is that as people move more and more towards these cloud-based architectures, the ability to synchronize two different systems becomes much simpler. Like the example that you said was perfect, right? It's that we can see our current rate of production. We can see how much stock is left. Let's automate purchase order creations, or this order's come in. I'll take it even one step further. This proof of concept that we did just recently with a customer, where they basically you have orders coming into the system, and those orders are for some customized set of parameters for a particular product. Some of those parameters will be extracted from said ERP system. They can be used to drive a 3D model and a setup and create the actual manufacturing information that's needed for that part, and then just automatically push that back out and then put it into a queue to be made on that machine. And then the operator is just working from a queue that's all just being generated by the fact that you have these three different systems all really coming together and just sharing data between them. I think that more and more those types of automations are the kinds of things that are going to become much more prevalent in these manufacturing companies.
Right. Do you think that, as far as the strategies go for some of these companies as they start to move forward in their plans for being 5 years out, is there a new technology that you plan to embrace or bring in and incorporate into your systems that will become part of the competencies that you guys currently have? Do you see something like that happening? I don't want you to divulge any company secrets and get in trouble.
No, of course not. Yeah, I think that there's a few things, right? I think that again, as you move towards a cloud data model, you also move towards the ability to have cloud-based computing, right? Racks of servers acting on your data as opposed to your local desktop PC sitting underneath your desk. You start to enable a much more powerful computation system. And what that really means from a practical user standpoint is that you can engage a system, like a design system, with more of a goal-driven design process. You can say, I need to create the lightest weight structure that will meet these strength requirements, but it's going to be manufactured from this process. And one of the other trends that kind of comes along with that is the move towards industrial metal printing and additive manufacturing and hybrid manufacturing, where you may 3D print metal structures and then go back and finish them with traditional CNC type processing. And this is something that I think is going to power an entire new generation of products, and the implications of 3D printing in metal is really, it's a whole new set of constraints and geometry creation methods that lend themselves extremely well to high performance computer figuring out the best design for you. You're not constrained by the limitations of our sort of traditional manufacturing processes. And so kind of the combination of those two things, I would say, is one of the biggest pieces of technology that I think that companies will be ready to embrace, and is going to have a huge impact. I think augmented reality and virtual reality technology as well is going to have a huge impact. You know, a lot of people are seeing, the impact of this in games and the consumer applications, but I think it could be argued that the industrial implications are even far greater. We think about things like, some of the stuff that you've been talking about workforce development and the skills gap. The idea of being able to do things like training and operator training and training for hazardous situations or training for failure situations, all of those things become so much more realistic in a virtual reality setting. And when you have manufacturing companies embracing technologies like that, you're able to create training and simulation environments. I think is one of the places where virtual reality will have a huge impact on manufacturing, as well as things like service, training, capture of information in terms of how particular processes are done. You look at people doing this today with just cameras and pictures, and by being able to leverage this wealth of 3D information that the design already contains, to leverage that for all of these downstream processes is going to be something that I think is going to be hugely impactful on the way that people operate in manufacturing today.
Absolutely. Do you think, I know that using some of the 3D software systems where you're actually designing in 3D and doing 3D product simulations, do you think that'll become a more accepted platform in the future? I know it's been very difficult to try and get people that have always been doing things in 2D to come over to the 3D world. Do you see more acceptance of that coming?
Yeah, absolutely. I mean, I think that you could just draw a linear plot, right, in terms of acceptance and just sort of standardization. I think that it's one of those things where as we make the tools more and more accessible to people, that you will find less and less of a barrier to entry, right? It's about, systems, in the beginnings of 3D design, right? You're talking about tens of thousands of dollars for a license of software and tens of thousands of dollars for a computer to run it on, right? And as computing technology and as the software itself becomes more and more accessible to more and more people, I think that you start to get people not just learning it at a much younger age, but even just being able to incorporated into places where they didn't even think that they would before, because, like I say, that barrier of entry to using it is so much less, and it becomes a much more intuitive process. And that's where I think that people will just become more and more accepting of it, and that it will just continue to become the standard in places where it isn't already even.
Wow. I know that I had spoken to a person from Ford Motor Company at one time, and they were talking about that they needed to move to a 3D system for doing their tooling in their automotive department for tooling. And one of the problems was that there was a reluctance to change over to it. But the benefits are that you can do a lot more true simulation and know where the true loads are within that tool in a 3D computation, that a 2D, you're kind of having to lie in different ways to create that. Has that been a challenge to illustrate that to people?
No, I think it's just one of those things that when, people have that sort of aha moment, right? And, I think that one of the things that we're trying to do is that you said it well when you say that, in this particular 2D environment, you're having to make some assumptions. Even looking forward to the things that we're working on, it's that the more and more accurately we can represent a particular design or a particular system, and the more intelligence you can put into it, of course, the more accurate you're going to be able to predict what's going to happen, right? So it's not just about tying that sort of 2D plan concept to the 3D model, but it's about having this single platform where we do not just a 2D layout, but we also create a 3D model, and then we create the simulation of that to understand its loads and impacts. But then we also prepare that model for manufacturing by creating tool paths or creating the program for its additive manufacturing, or define how it will be molded through injection molding, whatever the manufacturing process is that will create it. To be able to tie all of that information together into a single system, you're able to, with significantly less effort on the user's part, have a much better understanding of how that design is going to perform and how feasible it will be to take that design into production. And that's this power of bringing everything together into a single system and not having these kind of silos that we had in the past.
Yeah, I think that's a great way of putting it, that it is silos. It's a silo of not only of education, but of equipment, and in industries, because the same information exists, different industries, the same information exists in different technology platforms, and being able to break out of that and merge that together can yield some pretty interesting results. Tell me a little bit about where you think Autodesk can fill in some holes there as far as developing our workforce. What new products in 5 years will we be looking at that can help our workforce be better prepared when they get into the manufacturing world? I know you talked about some of the artificial intelligence and in some of the augmented reality and virtual reality systems. Do you guys see that is an area where you can do more training and things like that?
Yeah, I think so. I think that we have a really big focus on educating people how to use our software. I mean, if we're really honest with ourselves, some of our software is really complicated to use, right? And it takes someone with deep domain expertise to accurately characterize the fluid flow of a melted plastic into an injection mold, right? And so we have a huge initiative around creating learning content and making learning accessible to people across the spectrum of products, right? And like I said, again, you can look at those far extremes of these software that are do end up having very deep domain expertise. But then on the far other end of the spectrum, I think another thing is getting kids and youth more engaged in these types of technology at a younger age, that it becomes more just intuitive, right? My kids these days, my 4-year-old can completely navigate a touchscreen tablet, but my mother is still completely baffled by it, right? And so I think when you look at things like 3D modeling, it's the same thing, right? One of the things that I'm really proud of here at Autodesk is a product that we have called Tinkercad that has literally millions of users, and kids engage with that product as early elementary school. My 5-year-old son actually will play with it sometimes, and it's about creating just this muscle memory and this understanding of the basic concepts of 3D modeling, because they're interested in, I can create a 3D model and import it into Minecraft, or I can create a 3D model and then 3D print it. The foundations that they're building there is going to carry right into that next step when it says, hey, I want to create a 3D model of this mechanical component that's going to go into an engine or into the next level system as I get up into high school and college. And it's just about kind of making these bits of engineering and technology just more of just commonplace technology that will make it less of a gap that needs to be addressed anyways.
It isn't just for kids, because I know I use that.
Cool. Yeah, I shouldn't characterize it that way by any stretch. I mean, I think that, it's used by, that product in particular, right, is used by, millions of people. Absolutely.
It's outstanding for somebody who doesn't have a lot of experience with CAD programs and is just using it to build models that you can use on 3D printers and other things like that. It is an incredible program. And
that's what we think about when we think about progression, right? Which is that you have tools like that, and then you can progress into other products like Fusion 360 that I work on, which is just really, you're really getting into doing real in mechanical design, product development. But we also see a lot of people coming in who find that product to be more accessible, and you have so many people that are crossing these boundaries, right? Like the electrical engineer is now also needing to design the mechanical case, or the mechanical engineer is needing to do some basic circuit board development, and the software engineer is writing the firmware and now has to be able to also lay out the PCB board for his design, and then he has to even create the little mechanical enclosure that's going to hold the thing, that's going to be inserted into some other machine. I think that as you start to really break down these discipline barriers, then the accessibility of the software has to be such that you don't need that PhD in thermodynamics to just be able to create a quick 3D model,
Yes. Especially with the popularity of educational programs like mechatronics, which is kind of an all-encompassing engineering background for people, because most of these companies, I don't need specifically an electrical engineer or a mechanical engineer. I need somebody that can be a project manager but understands all of these things. And I know a lot of companies in a lot of schools have adapted these mechatronics programs, which are a little bit more holistic in their approach. So,
yeah, absolutely. Well, it's important, right? I mean, I just think that it's harder and harder to find a product these days that doesn't have a circuit board in it, right? Whether it's for simple data analytics and capture, or whether it's for robotics or controls, or there's this idea of this hybrid design, and all these different disciplines coming together into a single product. You need to understand this sort of multidisciplinary approach, or what would be considered in the past to be multidisciplinary, is now really just the entire discipline of product development, right?
Right. Well, hey, Patrick, it has been great. Thank you very much for taking time today to be on our show. And I really appreciate you taking time out of your busy schedule to be here. Thank you, sir.
And thank you so much. I was happy to be here.
Thank you. And this has been a great eye-opening look into the technical side of things and where some of the applications can be for the future of manufacturing and the destiny of manufacturing. And the Destiny of Manufacturing podcast right here has been brought to you by the Precision Metal Forming Association and the PMA's Educational Foundation. Thank you, everybody. Have a great week.